Okay, so let's do an example. By the way, I tried to choose examples that were from the homework problems and not from the book, so you can read the examples in the book and look at this for another set of examples. All right, so it says find capital F, so it's meaning their actual antiderivative, as a function of x and evaluated at x equals 2, 5, and 8. All right, and so they give you this problem. They say capital F of x is this function, 2 to x of t cubed plus 2t minus 2 dt, okay? So you could do this problem 3 times and you just change the x and then just solve it like a normal definite integral, but I would solve it first to get a function in terms of x. All you have to do is plug the x's back in at the end, okay? Either way works. Great thing about math, lots of ways to do things. All right, so if we do this, we have to take the antiderivative. Okay, so the antiderivative of t cubed is t to the 4th over 4. Antiderivative of 2t would be 2t squared divided by 2, which will simplify it a little bit. Minus 2, the antiderivative of that would be minus 2t, and we're evaluating it from 2 to x, okay? So you're going to kind of treat x just like it's just the constant b or just a number. So you're just going to plug that in first for all the t's. So here we go. And we simplified this 2 divided by 2 to make it just x squared. All right, and then we're going to plug in 2 for everything. Okay, so if you just bring all this down, and then if we simplify this, you get 4 plus 4 minus 4, okay, which simplifies down to minus 4, okay? So if you take care of all that, this is your function. All right, in terms of x. So then they want you to evaluate it at 2, 5, and 8. So all you have to do is plug in 2, 5, and 8, and then solve. So when you plug in 2, you get 0. When you plug in 5, you get 167.25, and when you plug in 8, you get 1068. Okay, so it accumulates area the higher the x values go for this function.